Hello. Oh, ah, darn it. Hello. I think you should see the desktop by now, and I'm trying to get everything working. Do you hear me now? You see the desktop? Does everything seem okay? Oh, okay. I'm looking at the chat. Okay. I don't hear anybody. I mean, somebody say something. Just make sure that I can hear things. I'm not sure if my. Uh,
Hello?
oh, hello. Okay, great. Thanks. Yeah. So everything does seem to be working. Okay. Good. Okay. So today we're going to talk some more about the if statements, and we're going to do the thing that's tricky with them. These things that are called nested if statements. Okay, we started that on Tuesday. We'll finish it today. Remember, there's a midterm exam a week from today. Next week we can look at these homework problems, these review problems, these practice problems. Okay, so definitely, your main point for prepare for exam is to do these practice problems. Make sure you feel comfortable with doing these kinds of problems. Next week, like on Tuesday, we can look at these problems. Anybody has any questions about them? Okay, we'll spend as much time as we can, like just solving problems. But uh, the exam will be about there's I think it's 20 problems on here, 21, and your exam will probably be about 10 problems. So it'd be about half the length of this thing here. Okay. Does anybody have any questions about it so far? Has anybody looked at this and had any questions about anything in it? Nothing? Okay. Yeah, if these are practice problems. If you have questions about them, you can. And remember, I said I'm not going to give a solution for them out. I'm not going to post answers to all these problems. But if you have questions about them, I'll answer questions. And if you want to know if you did a problem right, I'll look at your answer and tell you whether the answer is right. I just don't want to hand out a set of solutions that somebody can just try to memorize or something like that. So work on them. Make sure you feel comfortable with them. And if is there anyone that you're not sure about, just please ask about it. Okay. All right. So, um, okay, let me show you something. I had an example file. I forgot where I put it now. Okay. Here's an example file. I'll put it up on the course website after class. I didn't have a chance to put it up there before class. So, okay. Okay. Here's a way to think about if statements. Okay, so here's our starting point. This is what an if statement looks like. You put something you want to do here and here, and this is something that should be true or false. If this thing is true, you do what's inside here. If this thing is false, you do what's inside here. Okay, so programs can make choices. Programs can branch. We People think of this as branching or making choices, making decisions. Okay, the program checks something, and this will end up, as we'll see, we'll spend more time talking about this later, but this is where you test things like if an you can anything that can be true or false. So you can test numbers, you can compare things, but you depending on whether the answer here is some true or false, you do this or the other. Okay. Now, since you could put anything you want in here, you could put another if statement inside there. Okay, that's what's called nested if statements. Okay. So if this thing's true, then you check for this thing here. And then you do either what's in here or what's in here. Okay. Now, notice that I put the nested if else statement inside of the what we call the then part. if this, so we think of this, we read this as if this, then do that, otherwise or else do that. So I put the if statement inside of the then part. That, surprisingly enough, doesn't happen all that often in computer programming. What's way more likely is this. I mean, it's just kind of weird that this just happens to be the way. I mean, we'll see in a minute, like why this one works a lot better. What this one says is, if something's true, do this. Else, what happens is you check for something else. So here you're checking this when this thing is not true. Okay, so if this is true, do this, else if this is true, do this, otherwise do that. Okay, that turns out to be essentially that's checking for multiple cases. Okay, you're checking for this. If it's not true, then you check this other case. Other here, what you're really doing is you're checking in addition to, you're saying, if this is true, then you're saying, well, also I want this to be true. A lot of times when you have something like this, what you really could say is essentially is you're saying, I want, this one kind of boils down to saying, I want that and that. If something and something do this in here. Okay, but that's kind of what that works out to. But in fact, it's not the same thing because of the way the else works. But this is kind of saying, I want this and this. Okay. This is saying something different. This is saying, if this is true, do this. If this is false, if it's false, look at this other case. Then do this, otherwise do that. Okay. This turns out to solve a lot of problems. Okay. This turns out to solve, and then you can keep on doing this. You can, inside this one, see what we did is we started with an if else, and we put an if else inside of the else part. So we're down here with an if else inside of the else part. So inside this one, we could put another if else. Okay. So inside of this else, there's an if else. Then inside of the else, there's a if else. Then inside of the else, there's an if else. And then inside of the else, there's an if else. Notice that I didn't put it inside any of the then parts. The then part's still empty here. The then part's still empty here. The then part is still empty, still empty. So everything I've nested has been in the else part. Okay. What this is really saying is, this is saying, if this is true, do that. Otherwise, if this is true, do that. Otherwise, if this is true, do that. Otherwise, if this is true. And this is for checking multiple cases of something. It turns, and then we're going to do this. This is really impossible to read. You know, if this was what we were doing as programmers, probably almost nobody would be successful. This is becoming really too hard to read. But it turns out we can rewrite this in a way that's simpler. Okay, what I'm going to do here, I'll show you what we can do if we can rewrite this. Okay, this parentheses inside of the else clause, you can put, okay, what are these parentheses here for? The parentheses are there so that you can put multiple things inside the else clause. So you could say something like, do this, and then do that. Okay, so you can do two things. If you only do one thing, do this, you don't need the, now if you take away the braces, now you have a problem. There's a mistake in your code. You can't do two things without the braces. But if you only have one thing, you don't need the braces. Okay, so if you only have one thing in here, you don't have to have the braces. So if you're going to only do one thing, you don't need the braces. Okay, if you look carefully down here, there's only one thing in here. There's really only one thing. We call this is one whole thing. From the point of view of Java, that's one thing. So you don't really need the braces. Okay, there's only one thing in there. Okay, so every time I nested something, the braces didn't have to be there. So inside this else is this if. I don't need that brace, and its companion end brace. Inside this else is just this one thing, that if. Okay, so I don't need that else, and I don't need that else. Okay, keep on doing that. Inside this else, there's only one thing, that thing there. So I don't need this brace. I don't need this brace. And then one more. Inside this else, there's just this one thing. So I don't need this. And I don't need this. So I'm removing things that don't have to be there. And now I see that between this else and this word if, there's nothing but spaces. See, there's nothing but spaces there. Delete all the spaces. Between this else and this if, there's nothing but spaces. If there's lots of spaces, it's good enough to have just one space. Between this else and this if, there turns out to be nothing but spaces. So just put one space. All right. Now, oh, and there was one more here. Between this else and this if, I just need one space. Okay. And now I have a lot more indentation than I need. So let me just get rid of all the indentation I don't need. And this is now written in a real easy to read way. I end up with something that is easy to read. I haven't changed anything. From the point of view of Java, I've gotten rid of unnecessary things. I've gotten rid of unnecessary braces and unnecessary spaces. And now I've got something that looks like this. Okay, and we call this a if-else statement. And it essentially says, if this is true, do what's in here. Otherwise, check if this is true. If that case, do there. Otherwise, check if this is true. Now, notice that this is false. Okay, if this is true, I do what's in here. And I skip the else part. So I don't check anything else anymore. So if this is true, I'm done in here. If this guy's false, I check the else part. If this is true, I do what's in here, and I skip the else part. So I'm done again. I don't even check this, and I don't check that, and I don't check this. On the other hand, if this one is false, I go to the else part and check this. If it's true, I do what's in here, and I'm done. I skip the else part. So this is just saying, check this. And so essentially, this is a sequence of checks where if this is true, you do what's in here. Otherwise, you check this. Oh, if this is true, you do what's in here and quit. You're done. If this is false, you check what's in here. If this is true, you do what's in here and you're done. If this is false, you check this one. If this one's true, you do what's in here and then you're done. So you've got a sequence of if this is true, do this. If this is true, do that. If this is true, do that. If this is true, do that. So you're finding the first thing that's true and skipping all the other ones. If this is true, do its companion code. If this is true, do its companion code. If this is true, do its companion code. And then once you've done a condition with its companion code, you're done. Okay, so that's what this thing, see. So what I've done is I've taken that real complicated thing. We go back to the real complicated thing. Okay, this was the real complicated thing. It actually is this simple thing. And this is what we work with. We work with this thing, which we often call an if or an else if statement, because it's if, else if, else if, else if, else if. Then notice at the end there's an else. That's what we call the default case. If this is true, if this is false, 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 then you're in here. So if all of these are false, that's there. You don't have to have it. You could just drop it from there. And then there's no default case. If none of these are true, you don't do anything. Okay. If this one's false and this one's false, if this one's false, you skip to here. 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 If this one's false, you skip to the end and you don't do anything. So sometimes you do it that way, but more often than not, you have a default case that says, if all of these are false, then do this. So you have what we call a default case. It doesn't have to be there. Okay. So this is something in programming that we see a lot. You know, as we go along, we'll see that there's lots of logic. This is sometimes called case statements. If this case, do this work. If it's this case, do that work. Otherwise, if it's this case, do that work. Then once you figured out what case you're in and you've done your work, you're not going to be any of the other cases, so you skip. Another way to call this is mutually exclusive cases. You only do one of these. You never would do more than one of them. If this one's true, you skip all these others because of the else. If this is true, you do what's in here. Since this is an else, you skip all this else. Okay? So if this is true, you don't do any of these others. If this is false, you go to here. If this is true, okay, you skip everything else. So you would see, if this one's true, you do it. If this one's true, you do it. You don't do both of them, and you can't do two of these. In the way this is set up, there's no way in the world you could do this one and this one. You know, if you wanted, if you for some reason you need to do this one and this one sometimes, then you need a different way of writing the code. This is set up to say that there's either this one's true or this one's true or this one's true, or so it's exclusive cases. Okay, so there, it's a lot of times when we'll see that this is the kind of thing where you ask somebody to pick a number and they either pick 1, 2, 3, 4, 5, or 6. Okay, yeah, this would be when uh, when you have a situation where you either have one case or the other case, you have these mutually exclusive cases. This is how you would write the code, where you test for the first case. That's what you do in the first case. Test for the second case. That's what you do in the second case. Test for the third case. That's what you do in the third case, fourth, fifth case, however many cases you have. And then if none of these cases hold, you have this catch-all case, a default case. Okay. Okay. So like here's an example of that, like income tax brackets. You know, the income's either less than 10,000 or it's if the income is not less than 10,000, then you check if it's less than 20,000. Okay. See, income is a good income brackets are a good example of how this would work. If you're not less than 10,000, well, you still might be less than 20,000. If you're not less than 20,000, you might still be less than 30,000. So this is actually the case of everyone between 20 and 30,000. This is the case of everyone who's less than 10,000. This is the case of everyone between 10 and 20,000. This is the case of everyone between 20 and 30,000. This is the case of people between 30 and 40, between 40 and 50, and then this is the case of all the high incomes, everyone above 50,000. Notice I don't have to even write that. The else case here would be where this one's false, this one's false, this one's false, this one's false, this one's false. So this one turns out to be everyone greater than or equal to 50,000. See, but that's a comment. The logic is that this is automatically my default case. So it just everyone above 50,000, equal to or above 50,000. Okay, that's an example of how it would get used. Not everything in the world is set up. It works like this, but this logic comes up in a lot in programming of having mutually exclusive cases, mutually exclusive brackets, mutually exclusive choices. Okay, notice that I don't have to write. No, I'll put it as a comment. This is the case of everyone between 10,000 and 20,000. And this is everyone between 20,000 and 30,000. And of course, this one then is everyone between 30,000, 40,000. Now, notice I don't write that here. So here I could write okay, how would I, if you logically want to say you're between 10 and 20,000, you would say this. You would say that the income is greater than or equal to 10,000 and the income is less than or equal to 20,000. Okay, because that's what I say. It's between 10,000 and 20,000. But I don't need to write that. This is a tricky thing. I don't need to say that because up here I checked if someone's income was less than 10,000. If that's false, the only way that could be false is that you're greater than 10,000. So the only way you get to this word else is if this was false, so you are greater than 10,000. So this guy's redundant. I can put it there. Oh, and you don't write the word and in Java. You write and with 2 ampersands. I wrote the word and to make it a little bit easier for you to just read it. So yeah, I'm thinking this is saying your income is supposed to be greater than 10,000 and your income is supposed to be less than 20,000. Okay, I can write that, except in Java I would write it with 2 ampersand. But I don't need to put this part. It's redundant because the only way I get here is by failing this. Failing this means someone's making more than 10,000. So it's redundant to ask, is their income greater than 10,000? Same with down here. I could write this as your income is greater than or equal to 20,000 and your income's less than 30,000. But this one's redundant. I don't need to say that because how did I get here? By checking this and it was false. So it was false that the income is less than 20,000. Well, if that's false, then the income is greater than 20,000. So this one's redundant. I only get here if this one's false, so I don't need to check it again that the income is greater than 20,000. So one of the funny things about this is that when you read these brackets, you have to read them cumulatively. Okay. If the income is 5,000, you don't get in here. Well, but 5,000 is less than 20,000. So why don't you get in here? Because if the income's less than 5,000, you were in here. So you did this and you skip the else clause. So $5,000 income does this code, then skips everything here, skips the else clause. So 5,000 makes this true, but you never get there. So when you read this, you don't read it in isolation. Like you're not going to do this code if the income is $20,000. So you're not going to do this. 20,000 is less than 40,000, but you're not going to do this code because up here, 20,000, well, 20,000 was less than this. So you did this code for $20,000 income, and then the else said skip all this. So with $20,000 income, you never get to this thing here. You don't even get to this thing here with a $20,000 income because it made this one true. So you did this and you skip the else clause. This is one of the things that make this stuff when you have to learn to read it. You have to learn to read these things carefully. When you see this kind of thing, you say, well, I'm only here when this is false. So this includes the logic of this being false. And this includes the logic of this being false and that one being false also. Okay. And this one's only going to be true when it's also the case that this is false, and this is false. So I had to skip over this bracket, skip over this one before I even tested this one. So when I get to here, my income is definitely greater than 30,000. To get to here, income must be greater than 30,000. Here I'm checking that it's less than 40,000. So then I do this code here. Okay. So these things can be, these things are tricky because of the way the logic works. We do shortcuts. Like we don't put this thing here in here. We don't put the, income is, we don't say this because it's redundant. And it's real important to remember that we don't, even though this means between 10,000 and 20,000, we don't have to write between 10,000 and 20,000 because we've already checked that it's not less than 10,000. We know for sure here that we're above 10,000, so we don't need to check that we're above 10,000. All right, so we don't. So notice the comment here might say, everyone between 10 and 20,000, but you might, and then you say, well, okay, but I didn't need to check the greater than 10,000 because that's the opposite of this. All right. So whenever you have something in a program that says it's either A, B, C, or D, then you have something like if it's A, else if it's B, else if it's C. So you treat this as kind of just an idea. There is no such thing as else if in the Java programming language. You have what you have is this, but when you put that inside of that, you can abbreviate it as else if. And then you just drop the brace and drop the spaces, and you just think of it as else if. So it comes from this, putting an if statement by itself inside of an else statement. And then you abbreviate it to else if. Okay. There are some programming languages that actually that make this even a little bit easier to write. There's programming languages where you can write the word else if there. Now notice how it changed color. Else is a word in Java. If is a word in Java. This is a way of putting an if statement inside of an else. If I write else if with no space, it turned black because it's not a word in Java anymore. My editor keeps track of the words that are in Java and the words that aren't in Java. This won't work. There are languages that do it, that just let you type else if as if it was one word. Java doesn't let, Java just says you put the space in there. It really is else, then an if statement. It's an if statement inside of an else statement. Okay, it really is this if statement inside of that else statement. It really is this if statement inside of that else statement. That's how you should think about it. But it's so common to put this if statement by itself inside the else statement that we have a way of abbreviating it. Okay. Oh, and then let's see if I can fit this. This looks an awful lot like what I wrote just down below. It looks like if. Now, you have to be careful. This and this have completely different meanings. Okay. Here you're saying, if this is true, do that. And then whether this is true or false, you check if this is true. See, these are completely separate if statements. Okay, there's no else there. Okay, if this is true, you do this. And then here you say, but if this is true, do that. And it's got nothing to do now with what happened before. These are completely separate if statements. And sometimes you have this in a program. You just check one thing and do something. Then you check maybe something unrelated and do something else. Then you're checking for something else that might be unrelated and you have something else to do. Here you could do this and this and this because you could have something that makes this true and simultaneously makes this true and simultaneously makes this true. Up here, there's no way to simultaneously have something that makes this true and makes this true. See, there's nothing that's going to simultaneously make, well, yeah, the number 5,000 makes this true and this true. But remember, because of the else, if we make this true, we never check this one. Okay, so you read this one very carefully. This piece of logic could be true at the same time this piece of logic is true. Income is 5,000, but because of the else, you don't get here if the income is 5,000. If this one, if I took these here and made them like this one down here, if I got rid of the else's, then it's a completely different thing. It's no longer checking income brackets. It's no longer checking, so I can't write this comment here is wrong. Now it's not checking income brackets. Now it's just checking if your income is less than 10,000, you do this. If your income is less than 20,000, you do this. So you do this for everybody whose income is less than 20,000. Then you do this for everyone whose income is less than 30,000. So The people who have income less than 10,000, you do this for them, and you do this for them, and you do this. Okay. This is very different logic than this one here. They look almost the same. If I delete that, you can kind of see them together. Okay. That and that mean very different things. And and as we're learning the programming language Java, we're learning to read this stuff. It's like, it's like learning a foreign language. You have to learn the rules of the language, and little things can make a big difference. So this one is mutually exclusive cases. So this is really the bracket between 20 and 30,000. This is that bracket. There's nothing mutually exclusive here. This is all the people less than 10,000. This is all the people less than 20,000. This is all the people less than 30,000, because there's nothing to connect these. If this one's false, so you're above 20,000, well, if this one's true, then this one will be true also. Okay. So you have to be, you read, you look for this kind, when you see these, you read them differently. You learn to read these differently than if you just see if. If I put an else here, it's not a default case. If I put an else here, it's just an else for that if. If the income's less than 50,000, do this, else do this. Okay. Okay. So this would handle people less than 50,000, but it would also this would handle all the people less than 50,000, including the people who you did this, and this for, and this just handles people above 50,000. It's not a default case for all of these. It's just a default case for that one condition there. So this is only the else for that thing being false, as opposed to this else here was the default case for all of these. These are individual, mutually exclusive cases with a default case. Here, it would be wrong to call that a default case. It's only companion to that condition there. Okay, it can be real easy to mix up. If somebody wrote this in Java, I would tell them that they shouldn't write it that way. For example, what they should do is put extra space here to help people realize that these are broken up. But that else belongs to that if. Okay, this should be written with space between here, here, and here to help somebody realize that I'm not combining these. This you almost never would put. It actually is. You can put space there. Occasionally, somebody writes their code like that, but that's actually making it harder to read. That's taking something that's all one if statement and making it look like it's a bunch of if statements. So this would be a dumb thing to do. Okay, that would be a dumb thing to do. When you have these else ifs, you should write them all glued together, sort of, because they work together. If you have a sequence of if statements, if you make it look like they're glued together, you're actually kind of misleading people because they're not glued together. They're completely separate from each other. You test this. If it's true, you do that. Then completely separately, you test this thing. And then if it's true, you do that. This test is in no way influenced by this one here. Okay. And then if you wanted to, in the middle of this, you could put an else. And then this would be kind of hard to read because this else is only tied to that if. It's got nothing to do with any of these others. Yeah, so this would start making people confused. So you would go back to the right thing to do is say, well, that's separate from that, but those two are together. That's an if else together. And then there's another if by itself, and there's an if else together. Okay, so you use spacing to point out what's combined together with what is separate from each other. So you occasionally see people do something kind of sloppy and make it hard for people to read their code. Yeah, it's actually not that unusual to find somebody doing something like that and making it and just kind of not helping people read the code by not writing the code in kind of a nice way. It's like, in English, if you don't use punctuation, people can still read your English, but the punctuation is there to make it easier to read. Here, The spaces kind of act a little bit like punctuation. The spaces make it a little bit easier to read. They help you see how things are broken up. They're not required. Punctuation is required by your English teacher, but a lot of times when you're writing English, especially if it's an informal thing, you don't use punctuation. A lot of people don't put the punctuation to save time when they're writing, but in formal writing, you're required to have the punctuation in formal writing, but it doesn't really have to be there. Here in programming, you're not required to have those spaces, but your boss will make you put them there. Yeah, if you're writing code professionally, you will not, in most companies, that code won't be accepted. Whoever wrote it will be told to go back and fix it. That won't be accepted because it's too hard to read. You know, it looks too much like someone's writing this. We read this one way. This is mutually exclusive cases. This looks too much like that, and it would be considered a very bad idea. Don't write it like that. Just put extra spaces there. Okay, so you get used to these kind of ideas. A sequence of ifs is different than a chain of else ifs. This chain of else ifs logically works a lot different than just a sequence of a bunch of ifs. And when you have a sequence of ifs, you could have a sequence of else ifs too. Every one of these could be given its own else clause, okay, which is not unusual. But they're all completely separate from each other. This one has no influence on that one. If this one was true or false, it doesn't matter. You start here and do this one. Is it true or false? Okay, so you could have an if else, you could have an if else. Okay, right? So that's different than this chain of else ifs. Okay, now let's look at a piece. Okay, let's look at an example that uses this idea. Let me get it out of the. I have it. I haven't put it up on the website yet. I'll put it up on up after class. Let me get it. Okay. So let me open Dr. Java. Oh, I did this. The example we just looked at, I didn't open it in Dr. Java because if you look at it, it's not legitimate. It's not a legitimate program. I'm just writing if statements with, with nothing in them. So this is not a legitimate Java program. So I didn't open it in Dr. Java. Okay, it wouldn't compile. It doesn't have a class statement. Doesn't have a main method. So this is just a way to just talk about if statements. Okay, so it wasn't really legitimate Java. Here's a program that we want to look at that uses this idea of nested if-else statements. And Dr. Java started up the wrong way. So let me close it. Start it again. All right, this time started the right way. Open this file. Okay. Now, actually, I'm going to move this up to, I'm going to copy and paste it up into the Java visualizer because we want to watch it work. Okay. And what it is a program, very similar to the one we did in class. So it's very close to the example we played with in class the other day on Tuesday. Okay. But it's going to create a scanner and ask the user to enter a number between 0 and 5. Okay. And then it's just going to check which case the person had. Is the number between 0 and 1? Okay, now here I'm writing it I'm writing it as a bunch of if statements. Okay, so I actually should have this one written this way because I've written it as a bunch of if statements. But I'm going to end up changing it to else ifs because it's going to turn out to end up being that's what it should be. Is there number between 0 and 1? Is the number, so they enter a number and I'm calling the number n. So here's where I read their double from the console, like in your homework assignment. I'm reading one number, I'm prompting them for one number. It's like a game, and I want to see what number they gave me. What number? I asked for a number between 0 and 5, but I want to see what range it's in. Is it in the 0 to 1 range, or the 1 to 2 range, or the 2 to 3 range? Okay. So I ask, is your number greater than 0 and is your number less than 1? Okay, but then I ask, is your number greater than 1 and less than 2? But if your number is a half and this is true, then this can't be true. This can't be true, can't be between 2 and 3. Notice that these are really mutually exclusive. Like this program is correct, but it's not written well. It is correct. If the person gives me a number between 0 and 1, I print out between 0 and 1, and I don't print out any of these others. But my program kind of foolishly, after I get a number between 0 and 1, it keeps checking. Well, is it between 1 and 2? Is it between 2 and 3? Is it between 3 and 4? So I've got a correct program. It checks if their numbers, if it, in each range, but this is really mutually exclusive. Yeah, if the number is between 0 and 1, there's no reason for me to be checking if it's between 1 and 2. Okay, let's just copy this up to the Java visualizer. And now the Java visualizer doesn't talk to your keyboard. The Java visualizer, unfortunately, when you run a program that takes console input, the Java visualizer can't talk to your keyboard because it's a website. There's technical problems with this. So they came up with a little trick. You click this button for standard input. I want my program to have input. You type here what you want the input to be. Like I'm going to want the input to be, say, 3.5. That's going to be what the user types in. That's what this thing's going to read. This is going to read from this box. Okay? It's a clever trick. Yeah, they just could not figure out a way to make the website work, the Java program work with the keyboard. So they came up with the idea that ahead of time, before you run the program, you put in this box what you want the keyboard input to be. Okay, and you open that box up and you type what you want the keyboard to be, and then you click on Visualize Program. Okay, then they show you here what your input's going to be. So they remind you over here. Now I think they did kind of a dumb thing. They should have put this above the variables. It's actually laid out real confusingly. They made this look like it's a variable in your program. It's not a variable in your program. Yeah, they made a kind of a dumb mistake. This box here should have been above this stuff here. Okay, it's not a variable in your program. Okay. Okay. So, but anyway, they're showing you that box, what was in that box. That's what the scanner is going to read from. Okay. All right. So now I start running my program. Here's the scanner object. We don't really know what's inside that object, but we have to create the scanner object before we can use it. Now we give a message to the user. Okay. Please enter a number between 0 and 5. Now we're going to read their number and store it in N. Okay, and we're actually reading it from right there. Okay, so click forward. Now see that number got copied into there as if the user had typed it in. So we did the read and we read that number from that box. And you could do this more than, if you want to read 3 numbers, you could just put 3 numbers in this box ahead of time, and you can call next double 3 times and you could read in 3 numbers. Okay, now, okay, the number is 3.5. So here, this guy's checking, is it greater than 0? That's true. And is it less than 1? Well, this one's false. And wants both of those to be true. So it's true that it's greater than 0, but it's false that it's less than 1. So this combined thing is false. It's not greater than 0 and less than 1. It's not between those numbers. So I skip over that. Is it greater than 1? Well, that's true. Is it less than 2? That's false. So this is true and this one's false. So I don't have both of them. So the total thing is false. So skip over that. Again, is it larger than 2? Yes, it's larger than 2, but is it less than 3? No. Okay, so this one's true, this one's false, but the combined one is false. So I skip over that. Okay, is it greater than 3? Yes. Is it less than 4? Yes. So I got 2 trues, true and true. So this combined thing is true. So I go to the print. Okay, so I print this, but now I'm going to check this case. See, yeah, and here I really this notice I had to get to this case, so it kind of made sense that I check these until I get to here. But now this is where it seems there's no reason for me to be doing this. If I was between 3 and 4, I can't be between 4 and 5, so there's no real reason to check this, but I still check it. Is this true? No, this is false. Now notice now this one's true. Notice how the logic here, this one is true. My number is less than 5, but this one is false. So I don't have both of these. I'm not greater than 4 and less than 5. I am less than 5, okay, because our number is 3.5, but I'm not greater than 4. So I'm not between 4 and 5. So this is false, so I skip over it. Okay. Now this was a check for whether they typed a number that was negative or larger than 5. And notice that this one would say, give them an error message. See, this last test was checking that they typed a number that was between 0 and 5. So if they typed something that was less than 0 or greater than 5, now in our case, is n less than 0? No, it's greater than 0. Is it greater than 5? No, it's less than 5. So we don't have either of these true. So we skip over to that one. Okay. Okay. So this program does the right thing, but it's not written in a good way. Yeah. For example, if the number here is 0.5, that shows you a good example of how this program is doing a lot of needless work. Okay. So read in their number. Okay, so there's our number, 0.5. Okay, is the number greater than 0 and less than 1? Yes, it's a number between 0 and 1. So go to the print line, print, you entered a number between 0 and 1. But now the program checks, is it between 1 and 2? No. Is it between 2 and 3? No. Notice it's doing a lot of silly checks. If you were between 0 and 1, you certainly can't be between 1 and 2, 2 and 3, 3 and 4. That's why this really should have been else ifs. Okay? See, the else ifs they have the advantage that when we change this thing to else if, it prevents us from doing all these unneeded checks. So what we're going to do here is put an else here. Okay? Now, put an else if I fix one of them. Now, I'm not fixing the others yet. I'm fixing one of them. Oh, okay, I'm just going to fix one of them. Now, let's see what the program does. Visualize execution. My input number is going to be a half. Okay, is it between 0 and 1? Yes, so do this. Now, notice I'm going to skip over this test because I made it an else if, but I'm still doing this test. Notice I skipped over the 1 to 2 because it's the else of this guy. Since this guy was true, I skip his else, so I'm skipping this, but I didn't go through and do the other combines. So now I'm still checking this one, checking that one, checking that one, checking that one. Okay, so I'm doing a lot more checking than I need to. So what I really should be doing is I should make this an else to that one. Make this an else if. Okay. Now I've got it so that if this is true, do this, skip this, and skip this. But I didn't combine them all. I'll just go ahead and run it and see how it works. Usually you wouldn't play games like this. We're just kind of like I'm doing this for you to get used to thinking about how these work. Okay, so I get my number, it's a half. Okay, now I start the if stuff. A half is greater than 0 and less than 1. So this one's true. So I go into this part. Okay, I print. Now notice that since this one was true, I skipped this else, which is now all of that. See, the else is this big else if, else if. So I skipped all that, but I'm still doing this one and that one and that one, which are hopeless. I mean, the number was a half, So since the number was between 0 and 1, it cannot be between 3 and 4. So since I know I'm here, I shouldn't even bother to check this. I shouldn't bother to check this. I shouldn't bother to check that. So what I really want to do is make this finish doing this as an else if. Okay. Okay. And then, excuse me. See, that's an else if. Oops. Now, this one down here is a little bit tricky. Notice that this was the case where the number wasn't between 1 and 5. I don't even need that logic. I can just do that and say else. Because if you think about it, I'm checking between 0 and 1, 1 and 2, 2 and 3, 3 and 4, 4 and 5. If the number isn't between 0 and 5, what is left? All the numbers that are less than 0 and larger than 5. So I don't even need that last bit of logic. See, I don't really need that last bit of logic. When I make this a else, the default case, when I make it the default case, it already says the default here is everything that's now what I have. This is what's left is every number less than 0 or greater than 5. Okay, so what's left here is else every number. So I don't have to write the logic for that. I get that for free because I wasn't between 0 and 1, 1 and 2, 2 and 3, 3 and 4, 4 and 5. So I don't need this. I don't need the logic here. I can say else we ask for a number between 0 and 5. Okay, now if I visualize this, get my number. Okay, check if it's between 0 and 1. It is. Print this, and I'm done. See, it's very nice now. Now it's got the right logic to it. When you check, as soon as you found the case you're in, you skip all the other cases. So let's go and try a number that's bigger. Let's try a number like 3.5. Okay. Now we have to get to the case that we're in. We're in the case between 3 and 4. So we get the number and we see that we're not in the first case. We're not in the second case. We're not in the third case. Now this is the case we're in. Print, and we're gone. We're done. Once we were in this case, we didn't check that case and we weren't in the default case. So we do the minimum amount of work now. Okay. So now this thing is working right. It's doing the minimum amount of work. We've got these mutually exclusive cases. We're either in this case or that case or that case. We have to step through the case. There's no way to magically jump to the case you're in. There's no way to just magically somehow end up in this case. You have to say, it's not this one, not this one, not this one. Oh, it is this one. Then you skip the ones afterwards. Okay. If it's not this one, but it is this one, then you skip what's after. But you don't get to this case unless you've checked this one first. No, there's no way to magically just sort of jump to the right case. You have to check the previous, you have to say, it's not this one, not this one, not this one. Oh, I'm in this case here. Then I can skip over. Okay. Now, there's one last thing to make this program work better. Remember, if you're not between 0 and 1, okay, let me think. I want to, in a sense, this test is I want to fix this code with this test here. Okay. I want to do the idea. Remember, we said again, if you're not between 0 and 1, okay, I'm sorry. Suppose you are between, yeah, if you're not between 0 and 1, you know that the number is not less than 1. So here you're checking, but you're asking, you know that you should be a number larger than 1 here. Okay. If you're not between 0 and 1, you think, well, if you're not between 0 and 1, you're larger than 1. So you don't need to ask this. Okay. If your number is now less than 2, if it's not less than 2, it's greater than 2, so you don't need to ask this. If your number is not less than 3, it's greater than 3, so you don't need to ask again, is the number greater than 3? Okay, so you think, okay, I can delete that. Okay. Same again. If the number is not less than 4, you think, oh, it must be greater than 4. But if it's greater than 4, I don't need to ask that again. Okay. Okay. Now, this is actually broken. I've got a bug in my code. What I just said really wasn't quite right. Let me, okay, now let's visualize it. It'll seem to be okay. Okay. Read my number. I've got this number 3.5. It's not between 0 and 1. It's not less than 2. It's not less than 3. It is less than 4. Okay, print out and skip. Okay, it looked like it was working. Okay, but now watch if I change my number to -3. Okay, put in a negative number. Okay. Okay. Read my number in. Okay, I've got this negative number. It's not between 0 and 1. Uh-oh. Look, a negative number is less than 2. Now I say the wrong thing. You entered a number between 1 and 2, but the number was -3. I've actually created a bug in my code. I did what I thought was the right thing, but see, I thought it was the right thing. If the number is not less than 1, it's, then I need to check if it's not less than 1, it's greater than 1. So I didn't need to check here that it's greater than 1. But the trouble is, I didn't account for the fact that if it's not here, it could be a negative number. Okay, so here's how to fix that. The way to fix that is to make the first case. Think of the number line. What we should be doing is we should think of this like in a math class where we have a number line. So let me be able to draw a number line for you to remind you what I mean. Okay. I really should think of this, and this a lot of times these programs, because we work with numbers a lot, it helps to think about things like the number line. I'm just going to draw a picture of a number line. I'm going to draw kind of a simple picture of a number line. Okay, so here's my number line, and here's the number, say, -2. Well, I'm going to draw a number line like this. I'm going to build myself a number line. Okay, and I'm going to make this one -2, -2, -1. Then here's 0. Here's 1, 2, 3, 4, 5, 6, and everything that comes after. Okay. Notice that my cases are, that piece of the number line is one of my cases between 0 and 1. And that's another case. Now, my cases are actually a little bit tricky. When we start writing programs to work with code, we have to start paying attention real carefully. Like what is my case here? Do I include the 0 and the 1 in the case? But if I include the 1 in the case, then the 1 can't be in that case. See, they're mutually exclusive. So how should I handle the endpoints? Let's make it 0 up to, let's make it 0 up to and including 1. Then from larger than 1 up to including 2. Then larger than 2 and up to including 3. So notice that this case is not going to be from 2 to 3. The 2 will belong to the case below it. This case will go from just above 2 up to 3. Okay. Now, The cases are in order. There's the case between 0 and 1, then from 1 to 2, then from 2 to 3, then from 3 to 4, then from 4 to 5. Then what I did at the end was my else was everything above here and below here. That was that was the logic I had before. My logic in my program was, okay, I'll go back to it. Okay, here's the way it was. Okay, the logic was, if we think of it with a number line, if you're between 0 and 1, let's see, can I? It's gonna be a little bit hard to get these to fit together. Okay. If n is greater than 0 and less than 1, that's that case there. Then if n is strictly greater than 1 and less than or equal to 2, that's case 2. Then between 2 and 3, strictly greater than 2 and less than 3, there's the next case. So I'm marching down the number line with my cases. But then I get to the end, and my else is a little bit weird. My else is not everything above 5. My else is everything above 5 and also the stuff that's less than 0. And that's kind of weird. That's how my bug entered the program. My else case was really 2 pieces. And if I want, I can rewrite my program more using the number line, and my program will work better if I use the number line. So my program's bug was when I went over here and I got rid of what seemed to be the redundant checks. The idea that, well, if you're not less than 1, you're greater than 1, so you don't need to check for it. But when I got to this case, my logic included the negative numbers. So here's how I fix that. I don't need to, I'm going to go up here and make my first case if n is less than 0. My first case should be that whole part of the number line. Let's work across the number line from left to right. So all this is wrong. So my first case is if the user gives me a negative number, then I say we ask for a number between 0 and 5. So put that up here. Okay. Now, if the number is not negative, then I check, well, now this one's redundant. I can get rid of it. See, if you're not less than 0, you're greater than 0. So this one's redundant now. Now I don't have a bug in my code anymore. Okay. Now my program, because now I'm really marching down the number line. I'm doing a case that's all the negative numbers. That's this case. Then if it's not on this part of the number line, it's in the right half of the number line. So I know now that I'm in the right half of the number line. Now I'm only interested in, well, I'm in the right half, but am I between 0 and 1? So I only have to check, am I less than 1? Because if this is false, I know I'm in the right half of the number line. So the only thing I have to check now is, am I less than 1? Am I less than 2? Am I less than 3? Am I less than 4? Am I less than 5? And then the else clause now is everything here. Okay. Okay. So I have 2 clauses that check for bad numbers. The bad numbers on the left of the number line and the wrong numbers on the right of the number line. And my mutually exclusive cases are kind of like working my way down the number line. And then I don't have any more logic than I need to. So the advantage of this program, the way it's written now, it's just a little cleaner. There's no more logic than there needs to be. Yeah. Are you a negative number? That's a mistake. If you're not a negative number, you're a positive number. And now I want to know, are you one of the numbers less than 1? If you're not less than 1, you're greater than 1. And here I just want to know, are you less than 2? But I don't need any more the code that says that. See, that's redundant. Oh. I don't need to really ask, are you between 1 and 2 at this point? This part's redundant because I only get there by being not less than 1. So if I'm not less than 1, I'm greater than 1, so that's redundant. See, if I wasn't in here, I must be, yeah, if I'm not in here and I'm not in here, what's left? I must be out here somewhere. So the only thing I want to check is, are you less than 2? See, this makes the logic visualizes it. My first case is asking, are you over here? Well, if you're not in that blue part, you're all the way out here somewhere. So then but then I only want to know, are you in this range here? But I know that you're in this blue thing, so I only have to check, are you less than 1? So I only need to check now, are you less than 1? Okay. Then if you're not here, you must be here. The only thing I really care about is, are you less than 2? I don't need to ask again, are you greater than 1? So I can drop that. Now this is, so now this is the really elegant way to write this program. This is the right way to check if the numbers are in these different ranges. Wrong number, we don't want a negative number. Then we check between 0 and 1, between 1 and 2, between 2 and 3. Okay. And then once we've gotten to here, we ask for a number less than 5. If the user didn't give us one of these numbers, the only thing left are the wrong numbers larger than 5. So that's this last else. Okay. This is every number. Now here, this is every number greater than 5. Okay. At this point, we don't have to say it, but this is the case of everything greater than 5. Okay. All right. So notice we went through a sequence of different ways of writing this program. There's lots of ways to make it right, but this is the elegant way, the best way to make it right. And eventually, one of the things we want to learn as programming is, like, how do you make things the clearest, easiest way for people to understand? Once you're used to this is the clearest, easiest way to write this program that says, I want a number that's between 0 and 5 on the number line. And I want to know, are they in this band, this band, this band, this band? Okay, so the easiest logic for that problem is this one. Just think of it as working down the number line. You know, wrong things, okay? Anything less than 0 is wrong. Okay, but if we're less than 0, we don't need to check anything. If we know we're less than 0, none of this matters. So we skip over all of it. Okay. Once we know that they gave us a positive number, okay, we're positive. The only thing we need to check is it less than 1. Do the thing, do what's in that case. If it's not less than 1, we know it's larger than 1. What we want to know, we want to march down the number line. If we're not in that region, then we know we're in that. So let's just ask, are you less than 2? Because we just want to peel off the next bracket. So we just need to ask that. We don't have to ask, are you larger than 1 and less than 2? We know you're larger than 1 because of that. Okay. So now it takes practice to write this stuff. Okay. It takes practice to be able to write this code in this kind of nice way. And we'll keep doing examples, and we'll solve problems using these ideas. And over time, you get used to thinking this way. It takes practice to get used to thinking this way. And that's where coding bat becomes helpful. I gave you a couple problems on coding bat. Notice that there's a whole section here on logic, and that's where they give you tests on if else problems. Okay, so you can start doing these logic puzzles. Okay, this is practice with thinking in terms of if else, and also using the and or. Okay, so notice that it says here, if you do these problems, you're practicing if else statements and their combinations, nested if else statements. You're practicing using the and thing. Now here, notice I managed to write my code without the and. After I fixed my code, notice if I fixed my code really well, the advantage was I used less logic. When I got the code really working right, I used less logic. When I started out, remember, I started out with more logic. I started out with things like ands and ors. See, there was the and. I needed. I didn't really write it the right way. It was the program did the right thing. It's not a wrong program. This program does what we wanted to do correctly. It's just it does it in an inefficient, hard to read way. But there's the ands. So I'm checking. I want this true and that true. Both of them have to be true. When you ask for or, what you're saying is, I want one or the other true. This could be true. That's good. Then I'm here. Or that one could be true. That means I'm here. If they're both true, now in this case, I can't have a negative number that's greater than 5. Though sometimes you could have an or where both things are true. Okay, you could have an or where both sides are true, not with numbers. You can't be less than 0 and be greater than 5 at the same time. So you can't have both of these true. But when we write more other things, it's possible to write an or where both sides are true, and then you're still inside. The or is true. The or is true if one or both of the things on either side are true. Okay, so in this section on coding BAT, they test for you make you practice using if-else statements, ands, ors, and then also not. Say something is not the case. Okay, I actually had something in here that used that. What does it mean to say a number? Okay, go back to the picture on the number line. Oh, think of the number line picture. This case here was asking, are you to the left of 0 or to the right of 5? That's saying, are you to the left of 0 or to the right of 5? Another way to say that is this part here and this part here are not here. See? If you think of a picture, the stuff over here and the stuff over here is not in here. So I can write that logically this way. There's another way to say it. I'm not between 0 and 5. Now, it's a little bit more complicated way to write it. So instead of writing it this way in my Java program, I could have wrote it this way. They mean the same thing. I'm not between 0 and 5. It's the same thing as saying I'm less than 0 or I'm greater than 5. And in the picture, this blue area chops the number line into two pieces. The part that's in the blue and the part that's outside of the blue in the yellow. The yellow part is not in the blue part. Or another way to think of it is the yellow part is what's less than 0 or what's greater than 5. Okay, so the yellow part can be thought of as not greater than 0 and less than 5, or the yellow part can be thought of as less than 0 or greater than 5. Okay, so what's in this picture, the yellow part, the part that's not the blue part, can be written as that piece of logic or as this piece of logic. Either one would work. This one's probably easier to read. So that was the one I used originally. I'm less than 0. This is the case where the number was negative or larger than 5. Negative or larger than 5. Okay? But somebody else might want to write it. For some reason, you might want to say, well, you're not in the range we wanted to be in. So if you're not in the range we wanted to be in, that's a bad thing. But when I wrote my program the right way, I didn't need any of that logic, because if I went down the number line in cases, I did that case first, that case next, that case next, that case next. Then when I got to here, that was my else clause. Okay, so I had a case for this part of the bad area. Then I did this case, that case. Then I got to the end, and this was my else clause. Okay, so when I wrote the program the right way, the part that was larger than 5 just ended up being for free as an else clause. Okay, and so notice I'm writing a lot less logic. When I write the program the right way, it ends up being actually, and that's our goal. This is correct. but it does more work than it needs to, and it writes more code than it needs to. It's actually trickier to read to keep track of all this logic. Okay. Over here, there's much less logic going on. Okay. So this one's the better way to do it. It's got much less logic going on, and also it runs better. Remember, this one, if this was false, if this was true, you still check that and you check that and you check that and you check that. So if you think of computer time, you're wasting computer time checking things that can't possibly be true. If this was true, it's a waste of time to check this, this, and this. So besides being harder to read, having more logic in it, it also runs less efficiently. The right answer has runs very efficiently. Once this is true, all this is skipped. So you don't do any needless testing and you're writing less code. See, well, negative numbers, bad. Less than one, that case. Less than two, next case. Now you have, but here you have to realize that this means between one and two. See, now the problem here is the logic is a little bit trickier to read. When you get to here, you can't read that in isolation. The number 2 or the number 0.5 isn't going to put me in here. The number 0.5 doesn't put me in here. Now 0.5 is less than 3, but I don't get here if n is 0.5 because 0.5 was this case. So this case is excluding what came ahead. So I read this as between 2 and 3, but I have to know that. Okay, so it's a trade-off. You know, it runs better and it's less logic to write, but it's a little bit trickier to read. Okay, this has more logic to read, more code to run. It's not the right way to do it. This is the right way to do it, but it is it's tricky to learn to write this code, and it's a little bit tricky to read it. Okay, and we're out of time, but the main idea is mutually exclusive. You're only in one of those cases. You use else ifs when you can break your code into this one, and if it's this one, none of these. Or it's this case, and if it's that case, it's none of these. Mutually exclusive cases. A lot of times they're in the number line, not always, but a lot of times the mutually exclusive cases are ranges of number in a number line. But as we do more things later on, we'll see that the mutually exclusive cases don't have to come from a number line. They don't have to come from this kind of thing. But if they do come from a number line, it's usually helpful to think of it that way. All right. Okay. All right. So we'll stop there. Okay. I didn't put these examples up on the course website, so they'll be up there after class, or this probably not till this evening. So these examples are tricky. Okay. I'll put them up on the website. You go through them and just review them in your mind, why we switched, why did we work our way from this kind of wrong thing to this better thing. Try to remind yourself, like, what is it we were trying to do? What was wrong with this? Even though it does the right thing, what's wrong with it? Just because it does the right thing doesn't mean it can't be better. It does the right thing, but it doesn't do it a good way. Why did we want to go to this stuff here? So look at the code over and try to step through the logic of what we did. Why did we want to go from this one to this one? Okay. All right. So I'm going to quit there. If you got the last homework assignment was due last night. Okay. Or 2 days ago, there isn't a third homework assignment. The third one will be up there in a few days, but right now you have to study for the exam. Okay, so I'm not going to even put a third assignment up there because I want you to think about preparing for the exam. So your homework right now is the review problems, the exam review problems. That's your homework right now. Do these review problems. If you do those problems, you'll be ready for the test. Okay, so I'm not going to put another programming assignment up there until just before the exam, and it will be due a week or so afterwards. But your homework right now is, and if you haven't done this yet, you can still turn it in. If you're still working on the homework, please, you can turn it in late, It's up to me to decide if I give you full credit or partial credit, but definitely you'll get at least partial credit. Probably at this point, it's only a day or two late. I'll still be giving everyone full credit. So do turn in the homework assignment. Don't worry about it being late. It's better to turn it in and get partial credit, if nothing else, than to get zero credit. If you don't turn it in, you get zero credit. So, if you haven't turned in the homework assignment, please turn it in still, finish it. And your homework assignment right now is to do the review problems. Okay, so if you have questions about them, please ask. All right, so I'll go ahead and stop sharing. We'll meet again on Monday. On Monday, we'll definitely look at these review problems if anyone has questions about them. And then we'll go on and talk. This is the next section to talk about in the book, but it's not on the exam. So that'll be the next thing we talk about, but it's not going to be on the exam. All right, so have a nice weekend and see you on Tuesday. Bye.